Good afternoon, all of you. Today's lecture, we will discuss about voltage source inverter. As you all of know, inverter is a device which converts DC voltage to AC voltage. Its functionality is just opposite of the rectifier. Rectifier converts AC voltage into DC voltage. In the today's lecture, we will discuss voltage source inverter. Yes, in the short, it is also called as VSI. The basic principle of operation of any inverter is given here. It means we have DC voltage, constant DC voltage. How can we can change the DC voltage into AC voltage? So this is the basic principle of the operation of this is given here in the diagram in the figure 3.33.a and 33.b. You can see so the two symmetric circuit using transistor switching for generation of AC voltage from DC supply. You can see it consists of two transistors, NPN transistor and PNP transistor, which is consist of it is a combination of two transistors. There is a switch is given here, and R is the load. In the two second diagram in the B figure, you can see the it is a the switch the base the switching is it is sinusoidal wave, but it is square wave is given here in the base. In the both the circuit, transistor works as a common emitter configuration and interconnected in the push-pull manner. You can see it is a push and it's a pull amplifier. In order to have a single controlled signal for transistor switch, one the transistor is NPN and other is PNP type. The emitter and base are sorted as in the figure. You can see the emitter of both the transistors are short circuit because minus C and plus C is given here, and base of the two is sorted. You can see the base of both the transistors is sorted, and emitter is also sorted. Both the circuit require symmetrical bipolar DC supply. Collector of the NPN transistor is connected to the positive DC supply E, and PNP transistor is connected to the negative DC supply of minus E. You can see collector of the PNP is connected to the positive supply plus E, and collector of NPN transistor is connected to PNP transistor is connected to minus E. When load which has been assumed resistive is connected between the either short circuit point or power supply ground. You can see the load is connected here at this point. In figure 3 point, in the A, transistor works as active amplifier mode, which is sinusoidal control voltage of desired frequency is applied between the base and emitter point. You can see we apply the sinusoidal voltage in the figure A for the switching of the transistor. You can see the sinusoidal voltage is here. This is sinusoidal voltage applied between base and collector. When the applied base voltage positive, then PNP transistor is reverse bias and NPN transistor conducts in the load current. During the positive half cycle, this transistor will conduct, and this will act as a PNP act as a open circuit. When transistor is conduct, you can see similarly for negative base voltage, NPN transistor conduct and PNP transistor remains reverse bias. It means when positive voltage applied at the base, so one transistor will conduct, other will be off. When negative voltage applied at the base terminal, one transistor will be off and another is conduct. A suitable resistor is series with the base will limit the base current, keep the sinusoidal voltage applied voltage magnitude much higher than the base to emitter conduction voltage drop. Means we apply the voltage at the base is much higher than the drop of the across this base and emitter junction. In the figure is show the typical load voltage and blue color and base signal in the green color waveform. You can see the waveform. The waveform is not here, I think, right now. The particular figure shows that switch power loss of NPN transistor is more and more power dissipated at the conduction. Now we will study about second figure. Against the amplifier circuit A, the figure V works as a switch mode. It works as a switch mode. The conducting switch remains fully on, having negligible on voltage drop, and non-conducting switch remains fully off along with no leakage current. In the second case, we will study about the second case. In this case, here the square wave is used for the switching. Either it is either conducting or it is not conducting. There are two possibilities of the transistor. But here in the sinusoidal wave, you can see it's very like this. So some middle of the point, it is conducting, other is not conducting. So up to some leakage current will chance are present at this case. But at this case, the leakage current chance is very less. The load voltage of output of switch mode circuit is rectangular magnitude E. Now you can see that because the phase current is E, so we make it as the output current is base voltage is square wave which is given to the input of the transistors, both transistors. So voltage of the output will be also square wave of plus E or minus E. So figure B is a more useful. Here the voltage drop will be less leakage will be present in the both the transistors. So it is more practical circuit. But in the case we get the square wave at the output, but as square wave have more harmonics because it contains infinite number of ideal square wave contains ideal number of harmonics. So by using the suitable filter circuit, we can minimize the higher level number of harmonics. So we can get the fundamental component of the signal, that is sinusoidal wave. This is the another topology of the voltage source inverter. It consists of a DC link battery and DC link capacitor and two switches, Q1 and Q2 act as a switch. The working of the capacitor is here because to absorb the high ripple present in the DC voltage. In the DC battery, because it contains the both DC and AC ripples, which both contain DC and AC component of current. AC component of current will be blocked by this capacitor, blocking capacitor, DC link capacitor, and DC component current will pass through the transistor. To buy this topology, you can get any AC waveform by this EDC link battery. DC link current may conceptually decompose into two AC and DC components. The individual role of the DC voltage source and the link capacitor may be clearly seen with respect to DC and AC component of the DC current. You can see for DC component the capacitor acts like an open circuit and the steady state capacitor doesn't supply any DC current. The DC part of the current is supplied solely by the DC source. And AC part of the practically the DC source may have some resistance and as well as some part of inductance in series with the internal EMF. Since as we know, no ideal battery exists, so across the battery, across the DC source, there will be always a resistance present across in the series. And similarly with the resistance, some inductance is also present in across with the EMF. DC component of bus current, the source voltage appears across series in the internal resistance of the circuit, so that DC current will not pass through the DC link capacitor. But the AC component of current of internal DC EMF appears across the short circuit and series impedance. So that AC component of current will be passed through the capacitor, DC link capacitor, and DC link capacitor current gets divided into these two parallel paths. However, the high frequency component of AC mainly flow through the capacitor. The step change DC link current associated with the significant amount of high frequency component is essentially finds path through the capacitor. The DC source which have high frequency current, which is high frequency nature, that pass through DC link capacitor, and the fundamental pure DC will pass through the these switches. The main application of this coupling capacitor is to avoid any spikes present in the output waveform of AC signal. So any spikes, any ripple signal, high frequency ripple signal will pass through the DC link capacitor, and pure DC will pass through the switches. For DC input, for input DC supply, no series impedance, then DC link capacitor doesn't have any role. If it is pure ideal battery, there is no role of the DC link capacitor. But as we know, there is nothing like ideal battery exists. There is always practical battery contains a a resistance and inductor in the series with the battery. However, practical voltage have considerable amount of the output impedance. The supply line impedance not bypass a sufficient large DC capacitor may cause considerable voltage spikes at DC bus during the inverter operation. So the application of DC link capacitor, the high frequency component of DC current will pass through across this capacitor, and low frequency DC current will pass through the switches, so it avoid any spike present in the output waveform. This may result in the deterioration of the output voltage quality. If you don't block the AC high frequency component of DC current, that will deteriorate the output voltage quality of the signal. It may also cause non-conducting switches of the inverter. In the absence of DC link capacitor and the series inductance of the supply line prevent quick build up and fall current through the, and circuit behave differently from the ideal BSI voltage source inverter, where the DC voltage supply is supported allow rise and fall in the current as per demand of the inverter. So the main application of DC link capacitor, as I told you, it bypasses the high frequency component current and doesn't pass low frequency of current. So these are main applications of the DC link capacitor.